Welcome to this focused revision session for ICSE Class 10 Chemistry. In this lesson, we will quickly review the most important concepts from the syllabus. The goal is to strengthen your understanding and help you recall the key ideas that frequently appear in examinations. With clear concepts and regular practice, chemistry becomes logical and much easier to remember. Let us begin with the foundation of chemical behavior, the periodic table. The periodic table is arranged according to increasing atomic number, and many properties of elements show repeating patterns known as periodic trends. When we move down a group, the atomic size increases because additional electron shells are added around the nucleus. As atoms become larger, the outer electrons are held less tightly. Because of this, metallic character generally increases down a group, while properties like ionization energy, electron affinity, and electronegativity tend to decrease. Across a period, the trend is different. The atomic size gradually decreases because the nuclear charge increases and pulls the electrons closer to the nucleus. As a result, elements become less metallic and more nonmetallic. Ionization energy and electronegativity also increase across a period. These trends help explain why different elements react in different ways. Another essential concept in chemistry is chemical bonding. Atoms combine with each other to achieve stability, usually by completing their outer electron shells. One way atoms combine is through the transfer of electrons. This type of bonding is known as ionic or electrovalent bonding. In this process, one atom loses electrons and becomes a positively charged ion, while another atom gains electrons and becomes a negatively charged ion. The strong electrostatic attraction between these ions holds the compound together. Common examples include sodium chloride and magnesium oxide. Atoms can also form bonds by sharing electrons. This type of bonding is known as covalent bonding. When atoms share pairs of electrons, they achieve stable electron configurations without transferring electrons completely. Molecules such as hydrogen, chlorine, methane, ammonia, and water are examples of covalent compounds. Sometimes, the sharing of electrons is not perfectly equal. When one atom attracts the shared electrons more strongly than the other, the bond becomes polar covalent. Water and hydrogen chloride are common examples of such bonds. There is also a special type of covalent bond known as coordinate bond. In this case, both electrons in the shared pair are donated by the same atom, usually from a lone pair of electrons. This type of bonding appears in ions such as ammonium and hydronium. Now let us move to acids, bases, and salts. Acids are substances that produce hydronium ions when dissolved in water. A simple way to identify an acid is by using indicators. Acids turn blue litmus paper red. Bases, on the other hand, produce hydroxide ions in aqueous solutions. When a base dissolves in water and forms hydroxide ions, it is called an alkali. Bases turn red litmus paper blue. The strength of acids and bases is measured using the pH scale, which ranges from 0 to 14. A pH value of 7 represents a neutral solution, such as pure water. Values lower than 7 indicate acidity, while values higher than 7 indicate alkalinity. A salt is formed when the hydrogen ion of an acid is replaced by a metal ion or an ammonium ion. Salts can be classified as normal salts, acidic salts, or basic salts, depending on their composition. Chemistry also involves identifying substances through specific chemical tests. This area is known as analytical chemistry. For example, carbon dioxide can be identified because it turns lime water milky. Hydrogen gas burns with a characteristic pop sound when ignited. Ammonia gas has a strong, pungent smell and turns moist red litmus paper blue. These simple tests allow chemists to determine the presence of different gases and ions in a substance. Another important idea that connects microscopic particles with measurable quantities is the mole concept. A mole represents a fixed number of particles, specifically 6.022 multiplied by 10 to the power 23. This number is known as Avogadro's number. Using the mole concept, chemists can calculate the mass of substances, the number of molecules present, and even the volume of gases involved in reactions. It forms the basis of stoichiometry and chemical calculations. Electricity can also drive chemical reactions, a process known as electrolysis. Electrolysis is the decomposition of a substance using electric current. It occurs in molten compounds or in solutions that contain free ions. During electrolysis, reduction takes place at the cathode, while oxidation occurs at the anode. This process has many practical applications, including electroplating, extraction of metals, and purification of metals. The extraction of metals from their ores is studied in metallurgy. Metallurgy generally involves three main steps. First, the ore is concentrated to remove unwanted impurities. Next, the metal compound is reduced to obtain the metal. Finally, the metal is refined to achieve higher purity. The specific method used depends on the reactivity of the metal. Certain important compounds are studied in detail because of their industrial and laboratory significance. These include compounds such as ammonia, hydrochloric acid, nitric acid, and sodium hydroxide. For each compound, it is important to understand its preparation, properties, reactions, and practical uses. Finally, we come to organic chemistry, the study of carbon compounds. Carbon has the unique ability to form long chains and complex structures. Because of this property, it forms an enormous variety of compounds. Organic chemistry focuses on hydrocarbons and functional groups, which determine the chemical behavior of molecules. Common families of organic compounds include alkanes, alkenes, alcohols, carboxylic acids, and esters. Understanding patterns in structures and reactions makes organic chemistry far easier to learn. With a clear grasp of these concepts and consistent practice of equations, numericals, and past exam questions, you will be well prepared for your chemistry examination. Keep revising regularly, focus on understanding rather than memorizing, and chemistry will gradually become one of the most logical and enjoyable subjects to study.